bromide decomposes according to the following equation. A 0.64 mole sample of NOBr is placed in a evacuated 1.0 liter flask. After the system comes to equilibrium, the flask contains 0.46 mole NOBr. What are the concentrations of NO and Br2 in the flask at equilibrium?
If they've given you moles, the equilibrium expression takes concentration, so you need to do moles over liter over volume. And then if they've given you mass, you need to convert mass into moles and then convert moles into concentration afterwards.
In what situations do we need to convert to concentration, and what situations to moles can we use?
Your equilibrium expression always takes in concentration, and your ICE table, as far as we know at the moment, we will be doing it in terms of concentration. The ICE table is always in terms of concentration, guys. As you become more confident with it, you'll be able to identify some situations where it's better to write the numbers in the ICE table in terms of moles and then convert to concentration at the end. Yeah, but that's not something we'll talk about at the moment, because my whole time that I've been doing chemistry, I've only ever had to do the ICE table in terms of moles, like maybe once or twice. It's not very common. Okay, so I brought that up to you just to give you the heads up. As you get more experience, you might identify, hey, this question, I don't want to really convert to concentration yet. The numbers are too messy. It's easier to do it in terms of moles first. But your equilibrium expression always takes in moles, and your ICE table, eventually the numbers from the ICE table get used to put into your equilibrium expression. So at the end of the day, everything gets done in concentration anyway. Your ICE table is to track initial change in equilibrium concentrations. So first thing to do when you're setting this up is each chemical gets its own column. Okay, and then the ICE becomes the rows. Let me just write this equation out over here. All of them are gases, so I'm just going to ignore the states for now. I don't want to have to rewrite that out. And then we're going to go ICE. In this particular question, they're just asking me for the concentrations at equilibrium, which is just this row right here. So I don't need to sub it into an equilibrium expression or anything, even though I easily could. You just have to write out the equilibrium expression. But that's all they're asking for in this question. In this case, concentration is 1 liter. So 0.64 moles is just going to be 0.64 molar. And then 0.46 moles is just going to be 0.46 molar. So then I just have to put it in, and then we'll talk about the process to filling it out afterwards. So they tell you that they put 0.64 molar in a flask, which means that's what happened at the start, okay? Because it's not like the second you put it in the flask, it goes to equilibrium, yeah? So anytime you see words like that, where it's like, oh, I just put it in the flask, that probably means it's times 0, and that's your initial concentration. And then there'll usually be another sentence that says, oh, after equilibrium, this is how much there is at the end. So this 0.64 molar is my initial concentration, and they tell me it's NOBr. So that's going to be 0.64. And then just take a guess for me, guys. They told me they put NOBr in the flask, which means how much NO and how much Br2 do I have at the start? If they don't mention it, it's probably 0. This is initial time. So they just put my initial amount into the flask to eventually get the forward reaction to occur first. So if they haven't mentioned any of the other chemicals at the start, then it's going to be 0. And then your change, remember, your change is according to LCP, your change is according to your stoichiometric ratio, and whichever way the position of equilibrium shifts depends on LCP. At the very start, there's 0.64 molar of NOBr, there's no NO, and there's no Br2, which exists on the right-hand side of the equation. So which way is the position of equilibrium going to shift? Is it going to shift left, or is it going to shift right? Remember that if it's shifting to the right, it makes the stuff on the right. So the change in concentration for the things on the right is going to be positive. And then if you're shifting to the right, you make the stuff on the right, you lose the stuff on the left. So this is going to be negative. When we don't know the number, we give it an X, and then the X is according to ratio. So this is a number X, this is 2X, and this is minus 2x. Okay, and then normally what you do is you do I plus C equals E, yeah? So you add your initial plus your change to equal your equilibrium. Now in this case though, we can figure out what X is, okay? Because there's one number that I haven't put into my ICE table yet. What number is that? 0.46 molar, good, for NOBr. Okay, so 0.46 moles divided by 1 liter gives me 0.46 molar. So that's actually what I haven't subbed into here. All right. So normally you give the X for your change if you don't know what the change is, which is what we did with our graphing, yeah? But in this case, because I know what NOBR was at the start and I know what NOBR is at the end, I can figure out what the change was from 0.64 to 0.46. With that in mind, what must the value in this box be? Minus 0.18. So if you know 2 out of the 3 things for the same column, then you can figure out the third. Okay, so I plus C gives you E. So in this case, we had C missing, so C is equal to E minus I, which is 0.46 minus 0.64. So as long as you know 2 of the 3, you can figure out the third. So obviously, if the question gave you I plus C, then you can figure out E. If the question gave you C plus E, you can figure out I on your own. When you know the change for one column, you can figure out the change for the others because change is according to stoichiometric ratio. What's the ratio between NOBR and NO? 1 to 1. So if my change in NOBR is minus 0.18, what must my change in NOB plus 0.18? What's the ratio of NOBR and BR2? 2 to 1. So how do I get from NOBR to BR2? From 2 to 1, I divide by 2. So if my change in NOBR is minus 0.18, what's my change in BR2? 0.18 divided by 2, which is?
0.09.
For my NO, I started off with 0, and then my change is plus 0.18. So what must I have left over at the end?
0.18.
And BR2?
0.09.
So my answer to the question is A. If they ask you to write out the equilibrium constant, then you just piece your working out together. So let's say, for example, they gave you some initial concentration, some equilibrium concentration. From that, you know to set up your ICE table, fill it out. That's done. Separate the question into 2 parts. If the second part of the question says, what's the equilibrium constant? You know that after you finish setting up your ICE table, then you need to take those equilibrium concentrations, sub it into your equilibrium expression to get your equilibrium constant.